Now we continue the timing diagram of 8085. In the last lecture, we have discussed the machine cycles, different five machine cycles timing diagram. Now we will see the examples of a few instruction. So instruction timing diagram is a combination of all these machine cycles. Now first we will see the timing diagram of move immediate B comma 43. Now to draw the instruction timing diagram, we need to analyze the instruction first. Now what is the meaning of this instruction? 43 we are trying to move into the register B. Now for this what? Now here they have taken the location 2000. In a 2000 location, opcode is loaded. Now for this, what is the opcode? 06 is the opcode. And in the 2001, immediately whatever the data we specified within the instruction that need to be loaded. That is loaded in the next instruction. Now this is a 2-byte instruction. 8-bit data is specified within the instruction means what? It is a 2-byte instruction. Now this is the opcode. 06 is the opcode and 43 is the operand. Now to fetch the opcode needed 4 T states, and to read the operand needed 3 T states. So total 7 T states are needed to draw the diagram for the move immediate B comma 43. Now here you can see T1, T2, T3, T4. Now up to this is a fetch. This is a machine cycle 1 fetch, opcode fetch. Now T5, T6 are, you can write it as a 1, 2, 3 or 5, 6, 7. So this is for the second machine cycle, nothing but what? Memory read. So opcode fetch means what? Control signal is read only, memory read also, it is a read only. Now whatever the diagrams we have analyzed here, so this is the opcode fetch. Now this diagram as it is you have to write, and you have to combine the memory read. Now this diagram you have to combine. So both the diagrams if we combine, then that is the timing diagram for the move immediate B comma 43 instruction. Now this is here you can see that 2000 is the address. So 20 is the higher order address is placed on the higher order bus, and 00 is placed on the lower order bus, and ALE for first clock cycle, ALE is applied. From the first clock cycle, for the first clock cycle, ALE is applied. And after that it is 0. So when it is enabled, that time it is, bus is lower order bus is acting like a address bus, and after that it is acting like a data bus. So in the opcode fetching, opcode is placed on the data bus when the read signal is applied. Now this is a status. Now memory is accessed, that's why 0, and fetching is taking place. So both the signals are 1. Now for the fourth T state, so after the fetching the opcode, this opcode is loaded into the instruction register, and after that instruction will be decoded in this fourth T state. And after that what? After decoding that, microprocessor understand that immediately in the next location operand is there that should be loaded into the register B. So for that what? It will place the higher order address in the higher order bus, and 01. So next location is what? 01 is placed on the lower order address bus, and again ALE is enabled because here the address is accessing. So that's why ALE is enabled, and after that it is disabled for the for first clock pulse. It is acting like a address bus, and after that read signal is applied because the 43 is the operand which is stored in the memory location should be read. So that's why read signal is applied. So after applying the read signal, the whatever the operand is there, that operand is placed on the data bus. Now here it is a opcode. Now here it is a data. This in this case in the fetching it is a opcode, and in the memory read it is a data. Now coming to the status bits, it is 0 because memory is accessed, and for the read operation, what are the status bits? 1 and 0. So by combining the opcode fetch and memory read, this is the complete diagram for the instruction of this move immediate B comma 43. Now this is the one example, and the next example we will see the STA 50 to 60. Now this is the memory location. Now accumulator content trying to move, accumulator content is moved into the this location. Whatever the data is there in the accumulator, that should be loaded into the this location. Now for that what, there is a opcode. Now opcode for this instruction is what? 42. 42 is the opcode. Opcode is a 32. 32 is the opcode, and memory location is what? 41 and FF. So this program is this opcode is loaded in 41 and FF. So this is the opcode. So first it will place the higher order bus. Now here you can see this is the higher order. So data is placed, higher order address is placed on the higher order, and the lower order bus is address is placed on the lower order, and read signal is applied. Read signal is applied. Now, what is STA? STA means what? It is a 3-byte instruction. Now, 16-bit data address is mentioned within the instruction, means a 3-byte instruction. Now, after the opcode, lower order address is needed to be read, and after that, higher order address needed to be read. Now, after reading the complete address, now accumulator content should be loaded into this location. Means what? Here, how many number of machine cycles are required? The first one is what? Opcode fetching. Second one is memory read for the lower order address. And third one is again memory read for the higher order address. And after reading the memory location, accumulator content should be loaded into this memory location. Means what? Memory write operation should take. Now here we total how many number of machine cycles are required? Means what? 4 machine cycles are required. So one is the opcode fetching for any instruction. The first one is the opcode fetching. And in this instruction, the second two are the memory read, and last one is the memory write. Now here you can see opcode fetch, memory read, memory write, and sorry, memory read, read, and memory write. So 4 plus 3 plus 3 plus 3. So these are the total number of T states are required. Now here in this up to 4, same the memory opcode fetching, and the next one is the memory reading, and memory writing. See here, memory read, opcode fetching means read operation, and read operation. Coming to the last one, memory write. So write operation is taking place. So write operation is needed to be indicated. Now accordingly, status bits are shown here. So all these 4, if you combine together, then that is the instruction timing diagram for this STA 5 to 6A. Now similarly, now move B comma data or move B comma 43. First one, whatever we have discussed, that is same. Now coming to the move C comma A. Move C comma A means what? It is a 1-byte instruction. Move C comma A is a 1-byte instruction. And what is the opcode for this one? 4F. 4F. And where the program is loaded? Program is loaded in the 2005. So here opcode is in this location, opcode is there. So need to read the opcode from the, or need to fetch the opcode from this location. Now that is the instruction timing diagram for this. Only 1-byte instruction, only opcode is there. So only opcode fetch timing diagram is needed to be drawn. Now increment memory. Increment memory means what? So HL is indicating one memory location. Now that memory location content should be incremented, and again that should be loaded into the memory location. So for that what? It requires the opcode, though it is having only the one in only one opcode, only 1-byte instruction, but still it needed the 3 machine cycles. So first one is the opcode fetch, and the second one is a memory read. So which location, M indicating what? Which location it is indicating that need to be read, and that should be incremented. Now memory read means what? What is the memory location? 5012 is the memory location. That is incremented by 1 and stored in the next location. Now here you can see. So that is and stored in the HLP. That's why what? Memory read and memory write. So total 3 machine cycles are required. Now how to draw these machine cycles? Already we have discussed. All 3 we need to combine together. Now add M. Add M is nothing but what? Memory location we are adding with the accumulator. So for that what it required? So first one is a opcode fetch and the second one is a memory read. And for adding, no need of any timing, any clock pulses or T states are required. So once if the data is now already accumulated data is available within the microprocessor only, if it read the data from the memory location and that is placed in the microprocessor, then addition will takes place. Now for doing the addition, no need of extra T states are required. So for add M means what? Already one operand is in the accumulator, one more operand is in the memory location, need to read the operand from that memory location. So for that opcode, for any instruction, opcode fetching is a common machine cycle. And after that, depending upon the instruction, now we need to analyze. Now in this case, M means what? Memory location. From so need to read the memory location and whatever the data is there in that memory location, that is to be added with the accumulator. So only two machine cycles are needed. Once the data is brought into the processor, that is sufficient. No extra cycles are needed for doing the execution. Now coming to the STA address location means what? Storing the accumulator data into the address. Now already we have discussed here. This is storing the address. Now here address is specified, there the address is not specified. That is the difference. Now in byte. Now this in and out I will explain at the in the fourth unit. So fourth unit is completely uh, it is for the interfacing. So at the time I will explain the in and out operations. Now this is about the few examples of instruction timing diagram.